Okay, so this is 3.7, the chain rule. So this is another method of calculating derivatives, and it applies to composition functions. So for example, something like this. So let's say I have two functions, so f of x, so square root of x, and then g of x, it's 3x plus 1. Okay, so if I want to put one function into the other, so create this composition of two functions, so f of g of x. Right, so g of x goes into, basically, right, it's just, this is what's happening, so that goes in there. Okay, so I'll have that square root, and then we have 3x plus 1. Okay, so yeah, chain rule just allows us to calculate the derivative of something like this. Yeah, let's start with an actually different example. So example 1, and just something a little bit simpler. So I want to calculate a derivative, so find derivative. So f of x is x squared plus 1, and that's to the third power. Okay, so to find the derivative, let me just kind of quickly do the problem, and then I'll explain why and how it happens. So I'll have 3, and then x squared plus 1. This will be second power, and then times 2x. Okay, so basically what happened is something like this. So I'm calculating the derivative, right, of y with respect to x, so dy dx. So the first thing I do, I calculate derivative of outside. So this is derivative of the outside. Okay, outside. Okay, so this is, if I look at that original function, this is the outside. Right, so that 3. Okay, so you see that, right, this 3. It's kind of like, just in a sense, we're pretending that this is a variable, right? And in a sense, it's that variable to the third power, right? And you're calculating derivative of that. So derivative of the outside. And you see that the inside didn't change. Right, so let's write no change. No change to inside. Okay. So now it's multiplied by derivative of the inside. So derivative of the inside. Make it green. So inside. Right, so that inside was x squared plus 1, so right, so that inside is here, x squared plus 1, and here's the derivative, right, the 2x. Right, derivative of the inside, so we have derivative of x squared, so that's 2x, derivative of 1 is 0. Okay, so that's what's happening. And yeah, let's do another example, or technically what you could do, right, when you have something like this, f of x equals x squared plus 1 and to the third power. So you could just multiply it out, right? So it would be x squared plus 1 3 times, right, by itself. So quite a bit of work, but doable. And then x squared plus 1 here at the end. Right, so you could multiply it out. You could multiply this with this, and then this with this, right, and etc., etc., and finally you would get just a polynomial. And yeah, that would be a lot of work, but still doable. But then, of course, right, if you have, I don't know, if f of x is not to the third power, right, but let's say it's to the 8th power, so x squared plus 1 to the 8th power, then that's still doable, but difficult, right, if you wanted to multiply it out. But if you wanted just to calculate the derivative, that'd be quite simple, right? So f prime, derivative using the chain rule would be quite simple. And it would be 8, right? So that goes, right? That goes to the front, and then minus 1, right? So 8, and then inside is unchanged, so x squared plus 1, 7 times 2x. Okay, so yeah, so it's useful, and obviously, and let me give you a definition. Okay, so definition of that chain rule. It's quite interesting. Interesting. Makes you think. So we have y equals, let's say y equals f of u. So that is be a differentiable function of u, and then let u equals g of x. Right, so the same be differentiable function of, so function of x of x. Well then, right, so that f prime of x, right, so I'll take the derivative of that first one, dy, right, with respect to actually, let me just rewrite it like this. Okay, so dy dx, I'm taking derivative of the outside, right, and with respect to that u, kind of that inside function. I'm gonna show it to explain it to you on an example, and then derivative of the inside with respect to x. Okay, so we could write it like this. Maybe this one is simpler. So I have d dx, and we have the outside function f. G of x is the inside function. So that's gonna be, right, f prime, and that g of x is unchanged, times, here I have that g prime of x. Okay, so let me explain this definition on this one, this part. I think this one is easy to understand. Right? Well, basically it's kind of, right, these are equivalent, but I don't know, let me give you an example. So if f of x, this is supposed to be blue. So if f of x is that, let's do that example with x squared plus 1 to the third. Okay, so in this case, u is that x squared plus 1, right? Okay, then y is f of u. Right, so that's gonna be u to the third. Right, so I hope you guys understand. So this is u, right? So then the y is f of, we can right, assume it's f of u. It's going to be u to the third. Okay, so now if I'm calculating this, right, so I'm taking derivative with respect to u, right? So then I'm looking at this. So that's going to be dy du. Make it blue again. Right, so that first part, dy du, this one, right? Dy du. So I'm taking that u to the third, right? I'm taking this and taking a derivative of that, right? So it's going to be 3u squared. Okay, so that's what comes first, right? So that's going to be that 3u squared, right? Of course, u will be this, right? And now I'm multiplying it by du, so derivative of u with respect to x, right? So let me write it. So du dx. Okay, so taking derivative of this one this time, so that's gonna be 2x. Right, so then finally, let's just write it here. So dy dx. Right, so we have that 3. I'm plugging that u, right, x squared plus 1. This is plus. So I'm multiplying times 2x.